how many of these molecules are polar? The first one is SO3. First, we'll draw the Lewis structure. So it's O, S, O, and O. Now we'll try to see how many valence electrons do it have. So O is 6 plus 6 plus 6, and S is 6. So that's 24 valence electron. So now I will put the dots 2, 4, 6. So now we'll count it 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we have used up 24 valence electron. Next we'll draw the particle charges. So the big one is oxygen. So it will get S minus, S minus, S minus. And this one is S positive. So now we'll draw the bond dipole. So the bond dipole will go up to the negative, and this positive going to the negative, and positive going to negative. Now we'll have to draw the molecular geometry. O, S, O, O. This looks like a trigonal planar because there are 3 bonds and 0 lone pairs. So it's 0 because there's no leftover of valence electron. So it is 3 domain. So now we'll draw the particle the bond dipole. It's going this way, and this one going to the O, and this one going to the O. Since since all of the domains are the same on the center atom, the bond dipole cancel, and there's no net molecular dipole. So the molecule is nonpolar. So it is non-polar. So SO3 is not a polar. The next one is OFH. OFH has 20 valence electron, but there's only 16 in the Lewis structure. So there's 4 left over. We did the same step we did before. We find the particle charges and we did the bond dipoles. And there's 2 domains and there are 2 bond. So it is a bent. So now we'll draw the molecular geometry, and the bond dipole do not cancel, so it is a polar. So this one is a check. The next one is BeCl2. So we draw a Lewis structure, find the particle charges and the bond dipole. Then we'll draw the molecular geometry. So there's only 2 domains and it's linear. So the bond do not cancel. So it is a non-polar. So this one is not a polar. The next one is CCl4, and you will draw the Lewis structure, the particle charges, and a bond dipole. There are 4 domains, so that is a trigonal, and there's no net dipole, and since all the center atom, the same center atom, the bond dipole cancel, and there is no net molecular dipole, the molecule is nonpolar. So this one is X. The last one is O3. So this little structure is a little different because the O is double. So we will draw the molecular geometry and we'll still bring the double down here. And there's only 3 domain. And there's no net dipole because it do not cancel. So it is a polar. So let's check. So in this question, there's only 2 polar molecule. The common mistake is forgetting to use SO3, mistaking SO3 for SO charge of 2 negative 3, or forgetting the uptake rule, and when to make Renaissance hybrid, and incorrect calculation of valence electron.